experiment number 9 in design and analysis of algorithms laboratory is to find a minimum cost spanning tree of a given connected undirected graph using Prim's algorithm. So here we have defined a class called as Prims, in which we have overloaded its constructor. So as we already know, the name of the constructor shall be similar to that of the name of the class. So this constructor Prims takes three parameters. The first one is the weighted matrix, the adjacency matrix of the graph. N stands for the number of vertices and S stands for the source vertex. So in this constructor we have also defined variables like a single dimensional array visited with a capacity to hold 10 integer numbers there. This particular single dimensional array is used to keep a record of which all vertices have been visited. And U stands for the first vertex. V is a variable of the type integer which is holding or which stands for the second vertex, and K is just a counter variable, and sum is initially set to 0. This is where we go on adding the cost of the minimum edges that we discover in the construction of the spanning tree, and then flag is initially set to 0. This particular variable is used to indicate whether the minimal cost spanning tree exists or not. And then we have a variable called as min. So we try to store the cost of the minimum edge in it. So initially we start by setting all vertices as not visited vertices. So in the for loop where I ranges from 1 to n, we make visited of I is equal to 0. And then we start by marking the source vertex as visited. So S is our source vertex. We accept it as an input parameter in the function Prim, in the constructor Prims there. So visited of S, we will set it as 1. It means that we are marking the source vertex as visited, and then we initialize the counter K to 1. So after it, we shall now, using while loop, iterate through all the vertices until K is less than equal to n minus 1. Because I have already told, if there exist n number of vertices in the graph, then the minimum cost spanning tree may have n minus 1 edges in it, a maximum of n minus 1 edges in it. So therefore K shall range from 1 to n minus 1. So we start setting minimum value to infinity. So we set min is equal to 99, and then we now make use of both the for loops where I ranges from 1 to n and j ranges from 1 to n to traverse through the weighted matrix and select a minimum edge. So please note here I and j indicate the source and the destination vertices respectively. So if visited of I is equal to 1 and visited of j is equal to 0, it means that I is visited but vertex j is not visited. Then if I is not equal to j, it means that both are distinct vertices, and the edge that runs from I to j, the weight of the edge that runs from I to j is having a value lesser than min, then it is the smallest edge with the least cost. So therefore what we do is we replace the content of the variable min and we assign it with the cost of the edge coming from vertex I to j. So min is equal to wij, and then we put the value of the source vertex I into the variable u and value of the destination vertex j into the variable v. So this if statements are repeated for all the vertices or all the edges in the graph until all the edges are visited. So as soon as we visit a vertex, we shall now go on marking visited of v is equal to 1. That is, we start marking the destination vertex as the visited 1, and then sum is equal to sum plus min. So as soon as you find a edge with the least cost, then we add this cost with the currently selected edge cost, and then we increment the counter, and the entire while loop shall run for n minus 1 number of times. So then in the next set of for loop, where for I ranges from 1 to n and each time I is incremented by 1, what we do is from n vertices, if any one of the vertices is not visited, then the minimal cost spanning tree does not exist. So therefore we check this condition in the for loop for all the vertices by using the statement if visited of I is equal to 0. If this particular vertex I is not visited, then we set the flag as 1. If the flag is set as 1, it means that there is no minimal cost spanning tree in the graph. So let us assume that we have visited all the vertices, so flag is equal to 0. So coming out of this for loop, the next if statement checks to see if the flag's value is equal to 1. So if flag's value is 0, 0 equal to 1, the condition becomes false. So we jump to the else part of it, wherein we try to display the cost of the minimal spanning tree. Otherwise, if the condition was true, then it means that there were no spanning trees in the given graph. So now this program also has a method called as main, wherein we have created an object called as scan, which is of the type class scanner. So we have a two-dimensional array w, so with a capacity to hold 100 integer numbers in it, and S stands for the source vertex, N stands for total number of vertices in the graph. So then we ask the user to enter the number of vertices. So whatever the user enters is read into the variable n using scan.nextInt. Similarly, then we ask the user to enter the weighted graph. So weighted graph is a two-dimensional array. Therefore, we make use of pair of two for loops where I ranges from 1 to n and j ranges from 1 to n, and w of ij is equal to scan.nextInt. This is how we read the contents of the weighted matrix. And then we ask the user to enter the value of the source vertex. So S is equal to scan.nextInt. So once the weighted matrix and the source vertex are read, we now create an object called prims1, which is of the type class prims. So as soon as an object is created, its particular constructor is called. So to this constructor prims, we are passing the weighted matrix, the number of vertices, and the name of the source vertex. So now let us see how this program runs. So now let us again give the previous graph itself, that is the graph that we had used for crystals, into the Prim's algorithm also. So let us say we have 5 vertices there, and then the weighted graph of the weighted matrix of the particular given graph. So A to A we do not have an edge, A to B we have an edge with a cost 3, A to C is an edge with there is no edge, A to D also we don't have an edge. A to E also we don't have an edge. And then B to A, cost is 3. B to B, the cost is no edge. B to C, there is an edge with cost 1. B to D, there is no edge. So B to E, again there is no edge. C to A, no edge. C to B, cost is 1. C to C, there is no edge. C to D, the cost is 6. C to E, the cost of the edge is 4. Similarly, so this is our input matrix. So let us say the source vertex is again vertex 1. So we can notice here, so it is selecting an edge from 1 to 2 whose cost is 3, and then it is selecting a minimum cost edge from 2 to 3 which is 1, and from 3 to 5 it is going at a cost of 4, and from 5 to 4 it is coming at a cost of 6. So the minimum cost spanning tree is obtained at the cost of 14. So this is how the Prim's algorithm works.